Welcome back. We got another video for you. This one's going to be on some of the homework problems we have for today. And this one is on number 19. This was a requested dedication. I have some visitors here. We got the 3 W's. We're going to be watching the magic. So if you want to, say hi, guys. See? So this is actually a class where we're teaching this. So kind of weird, right? Let's do it. All right. So in this problem, we want to find the concavity and points of inflection. All right, points of inflection. So to figure out the concavity, we got to find out the second derivative. So we're going to go through and find the second derivative. We have a rational function, which is always fun to find the second derivative of. Yep, the people out here are nodding their head in total concurrence with me. All right, so from here, we're going to take and use the difference quotient. All right, we're going to take the derivative at the top, which is 1, times the bottom, which is x squared plus 1, minus the derivative at the bottom, which is 2x, times the top, which is x, all over the bottom squared. Make sure not to square too much in class. So, yeah, that's a bad joke. All right, so in any case, we're going to continue on, and we want to simplify this, and we have is x squared plus 1 minus 2x squared. When we go a little bit farther, this is going to be negative x squared plus 1 all over the quantity x squared plus 1, that quantity squared. I did not forget this over here. I just did not put it there, so don't freak out. All right, so now from here, we have our f prime. Well, we're not looking for f prime. F prime helps us find critical points in max and mins and increasing and decreasing intervals. No, we are looking for the concavity in points of inflection. So we're going to go one step farther and find f double prime. Are you excited? I know you are. All right, so from here, we're going to find f double prime, and we're going to use this simplified function because it's much easier to find the second derivative of that rather than this. Boo. All right, so from here, we're going to take the derivative of the top, which is negative 2x, times the bottom, which is x squared plus 1 squared, x minus squared, minus the derivative of the bottom now. We have to use the chain rule. Woo-hoo. That's always fun to do. Times the derivative of the inside, which is 2x, all multiplied by the derivative of the numerator, which is negative x squared plus 1. And then we take the bottom squared. All right, so we got x squared plus 1, that quantity squared, which is to the 4th power. All right, so all of this, we're going to find the second derivative. Now, obviously, I probably want to simplify it, because to find the concavity in points of inflection, remember that's what we want to do, all right, we want to set this equal to 0 or determine where it does not exist. Now, when you have a rational function, the 0 is when the numerator is 0. When the 0 is in the denominator, that's where it doesn't exist. Well, the denominator will never be 0 because it's x squared plus 1. So we're just going to concentrate on the numerator. So I'm going to set the numerator equal to 0. Okay, so let's take that puppy and let's simplify. From here, one of these things is just like the other. What can we factor out? It looks like x squared plus 1. We do that. We have negative 2x left over. We have x squared plus 1 right there. Then we got negative 4x times the quantity negative x squared plus 1. That's cool. And I think I'm missing a parentheses. There we go. All right. And then from here, I'm going to set that equal to 0. Simplify the inside. So we have negative 2x to the 3rd minus 2x plus 4x cubed minus 4x. All right. All that, and we have x squared plus 1. Just sitting there wondering, what about me? I'm not using you. All right, so from here, what we have, did I screw up, guys? Okay? I'm good. The bottom x, oh, it's like a carrot? Oh, sorry, that's an x. See, there is actually a student audience today, so they're helping me out, and I thank them. All right. This is a long problem, so we already just keep on going because nobody wants to watch a 9-10-minute video on one problem. Or maybe you do. Whatever. All right, so 2x cubed, simplifying this a little bit farther, negative 6x. And then we have x squared plus 1. Now I'm going to factor out a 2x because once again, remember, we want to find where the zeros are. So we got 2x, and what we have left over is x squared minus 3. Set equal to 0. Once again, I don't really care about you, but I'll still write you out. All right, now, look at this. Where are my zeros? I got a 0 here at x equals 0. And also, that part. We got plus or minus the square root of 3. All right, so from here, after we find our critical points, now we're going to do a sign chart. Sign chart. All right, so from here, we're going to lay out all of our values. We got 0. I'm going to go on the left side, negative square root of 3. Then we got the other side, it's going to be square root of 3. Right on my intervals, I got negative infinity to negative square root of 3. I got negative square root of 3 to 0. That's a 3, by the way. All right, and we got 0 to the square root of 3. And then square root of 3 to infinity. All right. Now, make sure you label your sign chart because I am testing this f double prime because f double prime will tell me stuff about f. And that's essentially what we want to know. All right, so we are going to plug in the value on the interval from negative infinity to negative square root of 3. I'm going to pick negative, what, studio audience? Negative 10. They wanted to put in negative 10. So negative 10. I plug it in here. I get positive, negative, positive. So it's going to be negative. All right. Plug in a value of negative 1. We'll plug in here. So if I plug in negative 1 into my derivative, so this was negative 10, just so you know, if you're playing along at home. Negative 1. We play this. We get positive. This one's going to be negative. And this is going to be negative. Negative times a negative is a positive. So we have that. I'm going to now go plug into 1 into my derivative. Second derivative, that is. Second derivative, we get positive, positive, and negative. Oh, negative. And then we plug in, like, I don't know, let's plug in positive 10. Positive, positive, positive. Are you positive? I sure am. And we have that right there. Okay. From there, if you're wondering, hey, Mr. Gutchalk, what about the denominator? Well, the denominator is the fourth power. That is always going to be positive, so whatever ones we have. So we just have to look at the numerator. All right, so I did not forget about that. I guess I probably should have said that in the beginning, but, well, all right, such is life. All right, but it will always be positive. That's good for us. Yes, that's good. All right, so from here, we're going to determine the concavity now, because that's our goal. We're going to determine the concavity. Well, when f double prime is negative, this is going to be f is going to be concave down, because f double prime is negative. When f double prime is positive, f is going to be concave up. Once again, when it's negative, it's going to be down. Then it's going to be up again. All right? It's like a roller coaster of emotions. See this problem? All right? You're always down, then up, then down, then up. All right. Now, those are our points of a concavity, and we determine that. Now, the next part is we want to find our points of inflection. Where are the points of inflection? Well, the points of inflection occur when f double prime changes signs. When f double prime changes signs. So points of inflection occur when f double prime changes signs. So, when does that occur? Well, we can see f double prime changes signs here. So here's a point of inflection. Point of inflection. That's what POI represents. Point of inflection here as well. And then we also have a point of inflection, a key right there at square root of 3. So let's write those out. We got, and we'll take this, and let's go back to our original equation. Woo, let's take U. Oh, man. Put it all together. Come on down. I apologize for the delay here. But just, please. Oh. All right. I hate that when that happens. And then I brought a green, and I brought a blue with me. Get back up there. Okay, so that's our equation. Now we have to plug that back into our original equation. So from here, we're going to plug square root of 3. So I have negative square root of 3. And back into here, so we have negative square root of 3 on the top. On the bottom, we have negative square root of 3 squared, which is 3 plus 1, which is 4. That's one of them. We have plug in a 0. So 0 on top is 0 over 1 is still 0. And then we have the square root of 3. Plug that on top. We have square root of 3. And then plug in the bottom, we once again have 4. So these are our 3 points of inflection. If you want to get a little bit more crazy, all right, you can also plug this in to our handy-dandy calculator. I'm just stuck in the bone marrow out of this problem. All right, and we are waiting for it to load. There we go, and waiting. All right, maybe we won't. Ah, there we go. Okay, so I apologize for the delay. And once again, we go x And then we have x squared. Make sure we divide. The studio audience saw that as well, but they just let me go on a broken path of not doing it. All right. What a great helpers they are. Just kidding. They're great. All right, now we graph this, and what we have then is you can see, all right, a weird looking graph. All right, I want to zoom in a little bit because just to test it out and look at our concavity, because it's always kind of neat to do that. If you wanted to stop the video right now and turn it off, I totally understand. But from here, you can identify. There we go. There we go. And on this interval, we notice that it's going to be concave. All right, up. All right, concave down. All right, concave down right here. Changing somewhere right here to concave up. All right, right here to 0, and then 0 is going to be this portion. Then going somewhere, it's going to change again. And then we have that right there. So where are these points going to be? Well, negative square root of 3, 0, and right here is going to be square root of 3. And that's where we find the points of inflection. All right, well, hope that was a good problem. Yep, they're clapping. All right, hopefully you're clapping too. But this was number 19. It was a humdinger, and hopefully this will help you on how to do further problems on how to find concavity and points of inflection. I hope you enjoyed it. Talk to you later, and look for future tutorials in, well, obviously, the future. Have a good day.